The tenant on the fourth floor is sweating through an all hands. Phones are blowing up because a tiny temperature sensor in a closet dropped offline.
Right? I've seen that exact scenario. One small reading goes weird, and automated sequences do the rest. What breaks if this goes down? That should be the first question on every map.
Exactly. Tenants call in minutes. Facilities gets heat calls. If teams don't have a clear dependency picture, you're triaging in the dark instead of restoring service.
Welcome to Built, Wired, and Secured. I'm Alex Morgan. Today we're talking about those invisible links inside buildings that let small failures cascade into tenant-impacting outages. Michael, James, thanks for joining.
Curious. Glad to be here. The practical thing I push for is clarity. Identify systems, their power and network dependencies, and who owns each node. That one clarity cuts hours off incident response.
And don't make the map an engineering schematic. Owners and ops need impact-first language. What fails, who gets a call, and how fast service degrades. Then technicians can dive into the appendix.
Let's get specific. What belongs on the owner-facing map, and what should live in the secured technical appendix?
On the owner's summary, major systems, HVAC, access control, elevators, security monitoring, plus primary dependencies, incoming power sources, external network links, and any cloud services that control operations. For each node, list the owner, the impact if it fails, and the immediate escalation contact.
The appendix can contain technical details, network segments, console endpoints, vendor support SLAs, and maintenance notes. But lock that down. Only vetted staff and contractors should see it. No credentials on a shared drive.
When you say mark single points of failure, how do you do that without turning the map into a shopping list for attackers?
Label consequence, not detail. Instead of radius server at 10.12.3.4, write central off controls building access and BAS. Critical, yes. Workaround, local badge failover. That tells decision makers what matters without exposing entry points.
Also note assumptions. Spare pump on site or manual badge override exists, because those things age out. If the map assumes a spare that no longer exists, you get a false sense of security.
Good point. Walk me through a lightweight way to create a useful map. Say I'm a property owner with limited time and I need something that actually gets used.
Run a 60 to 90-minute workshop, ops, IT, and one vendor rep. On a whiteboard, map major systems and draw lines for power and network dependencies. Annotate who to call and what fails. You'd be surprised. One focused hour yields far more operational clarity than a month of email.
Then make it a living doc. Put the summary in a shared read-only place and keep the appendix in a secure vault. Pilot on one building, validate it during a maintenance window, then scale. Trust the process. Discover, map, validate, schedule the next review.
I want to press on one point, granularity. Michael, you recommend listing vendor touchpoints and cloud services. James, do you ever push back that smaller portfolios can't staff that depth?
I'm not convinced every owner can afford an engineer to update a 50-node map weekly. For smaller portfolios, prioritize 3 critical dependencies, 1 fallback each, and a single tested escalation path. Keep it simple and actionable. Don't drown in details.
Fair. My pushback is this. Simplicity is fine, but contracts must require vendor accountability. Saying vendor manages this isn't enough. Insist on standby SLA, expected on-site times, and a named escalation. From an operational standpoint, those things change outcomes.
So compromise. A one-page owner map that highlights impact and contacts, plus a locked appendix technicians use. Owners get clarity, operators get the detail they need. That sound right?
Exactly. And schedule the map review as part of your maintenance calendar. If it's not on a calendar, it won't be updated.
Let's move to using the map.
How do you operationalize it so teams actually prevent outages?
3 places: commissioning, outage drills, and handoffs. During commissioning, validate every dependency. Does the transfer switch behave as documented? In drills, simulate a failure and practice the escalation. And include the map in any vendor or owner handoff packet so knowledge travels.
I run short scenarios. External network loss at 3 p.m. What happens to access control, BAS, and analytics? Time the response. In one case, a 90-minute drill exposed a 12-minute vendor callback delay. Fixing that cut outage impact dramatically. Preventative maintenance beats emergency repairs every time.
That's a great example. Real numbers help. Any quick rules for redaction and handling sensitive map content?
Keep the owner's summary sanitized. Consequences, owners, and contacts. Move console URLs, VLAN IDs, and admin steps to the secured appendix. If you must share sensitive details with a vendor, use an NDA and restrict access by role and time.
Label assumptions clearly. If an entry says temporary manual bypass available, add an expiration or verification date. That way, a stale assumption won't mislead responders during a real event.
Before we close, give our listeners 3 concrete actions they can take this week to start a dependency map.
1. Run a 60-minute cross-team workshop, ops, IT, and one vendor, and draft a 1-page map highlighting 3 critical dependencies and any single points of failure. 2. Document the escalation contact and expected response SLA for each of those nodes. 3. Schedule a 30 to 60-minute outage drill next month to validate one dependency.
I'll add capture assumptions in plain language and put a calendar reminder to review the map after any major vendor change or capital project. And if you lock a spares policy for critical parts, start one. Being able to swap a pump on-site often turns a 2-hour outage into a 20-minute fix.
If you want a starter template, GDS has a dependency map pack that includes a workshop agenda, an owner summary layout, and a secure appendix format. Visit gds-tech.com/dependency map to download it and run your pilot this month.
One closing thought. Treat the map like an SOP. Consult it during decisions, tests, and handoffs. If teams don't look at it, it becomes historical noise.
And remember, the best day in operations is the one nobody notices. Build the map so those quiet days stay quiet.
That wraps up this episode of Built, Wired, and Secured. Thanks to Michael and James for the practical, repeatable steps. For more info, visit builtwiredsecured.com. Run a short workshop. Document 3 critical dependencies and schedule a drill. Until next time, make sure the systems you're responsible for are built to last, wired with intention, and secured for the real world.